Hey guys, and welcome back to today's video. Today is another educational video, and today we're explaining about transformers. What are transformers and everything about them? No, those types of transformers, right? Those ones, okay? Transformers by Muhammad Video. What are the contents of this video? Introduction to transformers. What are they made up of? The working process, types of transformers, explaining them, the types of transformers, important keynotes, important equations regarding transformers, and the national grid. First of all, let's start up with what is a transformer. A transformer is a device. There are definitions, right? They included. A transformer, number one, a transformer is a device that changes potential difference of voltage from one value to another value, making it smaller or greater using the principle of electromagnetic induction. Number two, a transformer is an electrical device that transfers electrical energy between two or more circuits through electromagnetic induction. A transformer may increase or decrease voltage depending on the number of turns of coils that they include. Okay. What does it consist of? A transformer consists of two coils, one with a soft iron core. One of the coils is connected to a mains power supply or gas supply alternating current, is known as the primary coil, while the other is connected to any load component, for example a lamp, is known as the secondary coil. These coils must be separated from each other. So this is a diagram, that's something which is said right now. This is the shape of transformer, the whole diagram of it. This is the primary coil, the input. This is the iron core. This is the secondary coil. Alright. So this primary coil gets supplied alternating current. A transformer cannot be supplied direct current because a transformer never works in direct current. It only works in alternating current. This secondary coil, which is that's just connected to a lamp or any other component. The output, obviously. So this is the working process of a transformer. The changing alternating current in primary coil produces a changing alternating magnetic field which links through the soft iron core from the primary coil to the secondary coil. So this is the shape of the transformer again. The primary voltage, which is connected to a power supply, and the current is linking through the soft iron core into the secondary side, and so the component which is connected to the secondary side to supply alternating current. So there are two main types of transformers: a step-up transformer and a step-down transformer. We'll discuss them briefly in a while, but let's just review them. A step-up transformer. As you can see, the secondary winding is having more turns than the primary winding. Therefore, the voltage in the secondary winding is increased. This means if the voltage applied is 100 volts, it could be increased depending on the number of turns. It could be 200 volts, 250, 150, but it should increase because they increase the number of turns of coils. So that's a step-up transformer. What about the step-down transformer? Step-down transformer decreases the voltage. As you decrease the number of turns of coils, so the voltage decreases. You can see over here the voltage is 100 volts, and the voltage over here is 200, so it decreased. What about the current? The current is indirectly proportional to voltage. So when the voltage increases, the current decreases. When the voltage decreases, the current increases. What about the power? It stays the same. The power stays the same, 1000 watts. Alright. So yeah, let's discuss them briefly right now. Step-up transformer. A step-up transformer is a type of transformer that increases voltage from primary to secondary. More secondary winding turns than primary winding turns. It's called a step-up transformer. Over here we can see that the number of turns in the secondary coil is more than the number of turns in the primary coil. Therefore, the output voltage is more than the input voltage. A step-down transformer. A step-down transformer is a type of transformer that decreases voltage from primary to secondary. Less secondary winding turns than primary winding turns. It's called a step-up. It's called a step-down transformer. So this is just a small mistake, right? So the secondary coil over here, you can see the number of turns decreased. Therefore, the output voltage decreased. Therefore, the current increased because they're indirectly proportional to each other. Remember that, keep that in mind. So this is step-down transformer discussed briefly. So if the input in the primary coil is AC, alternating current, which is all the time because the transformer never works in direct current, and there are two types of current obviously, so then the output must be AC. It can never be DC unless you like apply a diode. That's another topic. So yeah, right. So this is the AC graph. This is a 1 cycle. This is a sine wave of the alternating current, time in seconds, and currents in amperes. So this is a video setting the alternating current in the transformer. This is the soft iron core, as you can see. This is the primary side, and the secondary side. Let's check this video out. Okay, as you can see, the current is alternating, going back and forth. The green dots are the electrons, obviously, because it's going back and forth. That's it. And I want you guys to guess which type of transformer is this. I'll give you a tip. What is the number of turns of coil? Yes, you got it right. It's a step-down transformer. The following is the symbol for a transformer. It's not that important, so I just gave you the symbol just for your knowledge. Step-up transformer, step-down transformer, and the following are real pictures of transformers. Transformers are very efficient devices. If you assume that they are 100% efficient, no energy wasted, which is impossible because some of the energy can be wasted through heat. Some of the energy cannot be linked in the soft iron core. Okay, let's get to the main point. Then the electrical input power will equal the electrical output power. Now let's calculate the power of the transformer. This is a really important equation which can come in your exam. The power incoming, P stands for power, equals the current in the primary coil. I stands for current, B stands for primary. The voltage in V, and IP, VP, equals the power outgoing, equals the current in the secondary coil, and the voltage in the secondary coil, IS, PS. Efficiency is never 100%, although it can be at 99%. Energy is lost if some of the primary magnetic field does not pass through the secondary coil. I'm sorry about that. Okay. Energy is also lost because some eddy currents. This one is not that important, right? So you don't need to get it much, right? So energy is also lost because some eddy currents are induced in soft iron core as well as in the coil. These eddy currents can be reduced by making the coil laminated from thin metal strips. This is the laminated core. This is a single lamination. This is a solid core with no laminations, high eddy currents. This is a laminated core with laminations. There are low eddy currents. Therefore, the efficiency will increase with laminations, and the energy wasted would decrease. The money used would decrease also. So that's our main point. This is the equation for finding the voltage and the number of turns of coils in the primary and secondary coil. This is a very important equation which always comes in the RGCSE exams. The transformer, I'm sorry about that, right? The transformer equation. VP over VS equals MP over NS. Potential difference in primary coil, potential difference in the secondary coil. NP stands for the number of turns in the primary coil, and NS stands for the number of turns in the secondary coil. You should keep in mind. This equation is very important once again. Now let's solve some equations regarding transformers. A transformer has 100 turns in the secondary coil. It sets up a voltage from 50 to 140 volts. Calculate, wait, for calculating, which type of transformer is that? From 50 to 240. So what's the type of transformer? You got it right. It's a step-up transformer. Now let's calculate the number of turns in the primary coil. The transformer equation. You should have remembered that or memorized that from the last slide, right? Now let's rearrange the formula to find the number of turns in the primary coil. MP is equal to VP over VS multiplied by NS, and that's after rearranging. So we're left with 100 turns in the primary coil. Now, a small key point, increasing the turns of coil results in, which is a step-up transformer, increases the number of turns in the coil, results in more voltage and less current. Decreases the turns of coil results in, which is a step-down transformer, less voltage and more current. This means that they are indirectly proportional to each other. What's the inertial grid? This is our final topic, right? The inertial grid consists of transformers and high voltage cables. The inertial grid connects the power stations to the homes. That's how we get electricity, right? Energy is always lost in the power cables. The bigger the distance between the power stations and the homes, the greater the energy loss. One way to reduce this energy loss is to make the power stations near to the homes. But nobody would accept that idea. Nobody would want to have power stations. Nobody would want to open his window and then find out that there are power lines in front of his home. It's impossible, right? That's our main topic. We can use electricity to transform energy from the power cables to the homes with less energy loss. How can we do that? First, the electricity passes through the step-up transformers, which increase the voltage. Therefore, the current will be less heat will be produced, and the energy loss will decrease. That's a brilliant idea. However, the voltage will be so high in the power cables, and that can pass in our homes. So we use a step-down transformer, which decreases the voltage, therefore increasing the current. Therefore, you can live happily. Okay, let's discuss this picture. A power station is having high current and low voltage. There's a step-up transformer. It steps up the voltage in the power lines, and the current decreases. Then it undergoes a step-down transformer, which decreases the voltage and increases the current to the consumer. And that was the end of the video. Hope you got everything in this video. If you have any doubts, just put them in the comment section below. I'll make sure I'll answer every video. And thank you guys for watching. I'll see you guys in the next video. Take care and peace.